Hello, everyone. We are back with another speaker, another amazing, wonderful session, and most importantly, another session for you all to be, more inspired and get all that enlightenment from. So yes, I would like to invite and I'm really happy to have Tam Kbeili amongst us as a speaker. He's a serial entrepreneur, leader, and founder of multiple startups, including one of the original coding boot camps, CodeCore. He is the CTO of Aplicar and the co founder of CodeCast, which is built using mainly Elixir, Phoenix, and React. Tam is also a passionate coding teacher, a polyglot software engineer, developer, and an expert in many languages such as Elixir, Rails, JavaScript, and Java. Wow, he's going to talk about building high performance applications with Elixir and Phoenix. Well, I welcome you, Tam, to this conference and for being a part of the speaker. Thank you so much.
Thank you, Iza, for the nice intro. Hello, everybody.
I'm giving the
Um,
floor to you.
yeah, hello, everybody. Really nice to meet you all. And thank you, VanHack, for having me over, presenting to you here about Elixir and Phoenix. So I'll start sharing my presentation here. All right. So today I'll talk to you about building high performance web apps with Elixir and Phoenix. So, um, Iza, I think, made a great job introducing me. I'm currently the CTO of Aplicar, which is a platform that helps schools recruit international students. And I'm the co founder of a platform called CodeCast. I'll show you a little bit more about CodeCast later. In brief, it's a streaming and video platform for developers. Here's my contact information. Would love to hear from you down the road. You could find me on Twitter, LinkedIn, and such. So, just to give you a little bit of a background about me, so you could know where the kind of the influences of what I'll talk about today. You could think of me as a part entrepreneur and then part developer, mostly backend developer. So when I pick a technology, I like to pick something that is practical, that basically you could build and ship applications with, and also it's fun to write with. So I enjoy writing code and I enjoy building things that solve particular problems. So that's why I always seek things that are both practical and fun. And you will see why how that influences kind of the decisions for them. In terms of my language background experience, I've worked with Ruby on Rails, Indeed, and JavaScript. And by the way, those were the two languages we taught in the coding bootcamp I started and sold a couple years back. Um, we taught Ruby on Rails, and we taught JavaScript. Those were the two primary languages. Of course, we taught other things like HTML, SQL, and so on, but those were the primary languages. Previously, I coded in Java, PHP, and C Sharp, but mostly Ruby and JavaScript. So today I'll tell you a little bit more about Elixir, which is a language I've been really loving for the last number of years, and it's the one that we actually use for both Aplicar and CodeCast. So it's a language that's been created by this guy. His name is Jose Valim. You can find him on Twitter. Very nice guy, very smart guy, and quite responsive actually for how busy he is. But before talking a little bit about Elixir, we should know a little bit about Erlang. So what uh, because Elixir is a language that is built on Erlang. It uses the Erlang virtual machine. So what happens is you write Elixir code and it compiles to what's called the beam, which is the Erlang virtual machine. So let me take a little bit of some time here explaining what this means. So Elixir is a dynamic language. It is compiled, so it does get compiled, and you do compile to the Erlang virtual machine. If any of you have come from Java, you could probably see parallels here. You have the Java language, which has the JVM that compiles to, but you also have all these other languages that also compile to the JVM. In a way, that's a similar idea. Erlang is a language that's built way back in like the 80s by Ericsson, and the name kind of imply Ericsson language, Erlang. It was built for telephony switches, so they wanted a language to help them um, basically manage the telephony switches. So they wanted a language that is fast, fault tolerant. So Erlang has been a very, very solid solution for this. The problem is Erlang is really not the most welcoming language. It's really hard. I shouldn't say very hard, but it's quite much harder, at least than Elixir, to write code with Erlang. So basically Elixir, inspired by Ruby syntax, came up with really good, nice, elegant, and fun syntax that when you write code with, it's really easy, relatively easy to read. It's it's a functional language. It is fast. It is elegant, and it's really approachable. So many of you probably heard of these functional programming languages. There's many other programming languages out there like Haskell and Clojure and such, Scala and some other languages too. Some of you may even have done like functional coding in JavaScript, and I'll talk a little bit more about functional before a little bit later. Um, it's very fast language. It's really elegant and very approachable. Just to show you an example for Elixir, um, just I'll give you maybe just like 30 seconds here to try to look at this code, which is Elixir code, and try to guess if you can tell what this code is doing. So, as many of you may have guessed, this is a code that takes a string and then it downcases it. It trims the string, meaning it removes trailing and ending spaces, and it removes any duplicate spaces with a single space. So again, my guess, my hunch, and it happens in almost every presentation I give about Elixir, is that anybody with a number of years of experience would look at this code and will guess relatively quickly what it's doing, which is not usually the case in Erlang or some of the other languages that you may encounter. So um, one very important aspect about Elixir is that it is functional. I know some of you may know what's functional, but I'll spend a little bit of time talking about what functional programming is, because many of you may be coming from languages that don't really enforce or don't really, um, um, you know, like you can write functional language in any functional programming in any language, but some languages enforce it, and that have some key advantages. So, getting a little technical here, I hope many of you are developers and wouldn't mind that. Is that there is this concept of immutability. Immutability basically, it's if you have some data in memory. So let's assume this thing on the left here is memory, and I have some function here. So if I have basically different bits of data stored in memory, and there is a function, mutability means, which is an unfunctional way, call it immutable way, is that the function can go to that spot in memory, and that basically function can modify that memory right in space. The functional way is that you make a copy of it, and then basically, so you have a function that looks at the data and then makes a copy of it. So the original one is still there, but you just made a new copy of the original data. So that's the key thing about functional programming. I mean, there's many other aspects. I'm a little bit simplifying here, but like this seemingly simple thing has huge implications for how you write your code. In many languages, there's all these handy functions and things that actually mutate data in memory, so it ends up having some side effects. In part, basically, Moore's law is dead. That's what I'll talk a little bit more about here. So why do we need functional? Why do we care about functional? So first of all, I'll have to say here a little bit about Moore's law. So Moore's law was, saying that basically he was one of the founders of Intel, the chip company, and he basically his law used to state that every 18 months we'll double the number of chips in a microchip. So, for example, you started with 1,000 chips. Next year, you'll have 1,000 transistor in a chip. Next year, you'll have 2,000 transistor in the same chip. by improving the technology, by improving the manufacturing techniques and stuff. Now, the year after, you'd have 2000, and so on. And that, by the way, held true, fascinatingly, from 1980 all the way to like maybe 2005 to 2010. So what starts to happen then, we're just hitting physical limits of the ability to put more transistors on a chip. So there's issues with how small we can make transistors, and also there's issues of heat dissipation because transistors emit heat. So we start to basically have too much heat emitted from too many transistors. So again, not enough technology to dissipate those. So you're starting to see this thing tapering off, basically, right? And by now you're probably noticing that you're not getting processors that are much faster. So, for example, you're probably aware, like Apple announced a new M1 computer, or I should say M1 chip. They put on their Macs and MacBooks. And if you notice, this M1 chip doesn't say, well, it's faster. It says it uses new architecture and it has more cores. And that's what we'll probably be getting a lot more down the road. We will be getting, I mean, maybe there's some improvements with architecture that can give us a little bit more speed, but more likely, we will basically, what will happen is we will be getting processors that have many cores, and some of these M1 processors come with 32 cores or 64 cores. You'll see some crazy number of cores happening there. So the thing is, functional programming makes parallel programming easier. Okay, and that's a key thing here. Why I believe down the road we're going to see a lot more functional programming becoming more and more important, growing in importance. Because what happens is you want to try to take advantages of the many cores in the processor as possible. If you're doing single-threaded programming, you're only using one core. But if you're doing multi-threaded programming, then you could take advantages of many cores. And functional programming makes parallel programming easier. You don't need functional programming to code in parallel. Indeed, many of you have probably done it in like C, C Sharp, Java, many languages you could do parallel programming. But the thing is, if you start to use functional programming, because you're not mutating data in memory, that is one of the hardest things to solve when you're doing parallel programming. The ones of you who've tried it before, you probably had to use some semaphores, you have to use locks, you have to use different techniques and things to just make sure that there is no two threads at the same time that are like reading and writing to the same spot in memory. So if you by design do not mutate memory, so at least that problem goes away. And the Elixir, what actually happens is many of the even underlying libraries take advantage of this. So they already do parallel processing for like when you're, say, going through data structures and things. A lot of these already take advantage of it. And in my opinion, also it enforces good habits as well. Coming from Rails, I know like we used to face a lot of problems that come from one bit of data like unintentionally mutating another thing, and then you get all these side effects. So I like to say that like Elixir, by kind of having you not mutate the data, enforces these good habits. I usually liken it to the fact that like if you want to go on a diet, it's probably better not to buy chocolate chip cookies and put it in your house. I mean, technically, you could have the chocolate chip cookies and not eat it, but likely if you have it available at some point during stressful times, you will just go and reach out to the cookies. Similarly, if a language kind of enforces good habits, it's like not having the cookies in the first place. So it's not even an option. While with other languages, you have to use your willpower or some other techniques to enforce a good habit. So it's good for the language to basically enable you by design to enforce you to have good habits. And another thing here is, in my opinion as well, is if you start to look at functional code, you realize it's a lot simpler to follow, because what you see is you just see a chain of functions. So one function that calls another function that calls another function. And every function is not going to mutate some piece of data that you have to worry about or you have to be concerned about. All you have to know is what does a function take in as input and what does a function takes out. I have to tell you, it's a little bit harder to code with in some cases. Sometimes coding with mutable data structures is easier, and sometimes it's a little bit faster as well, given the same language. That said, the upside of having more organized code and taking more advantage of cores, I think, outweighs that negative side. Also, testing and refactoring is easier, I find, with functional languages, because again, a function has an input, has an output. That's all you have to worry about. You don't have to worry about, like, oh, I have to make sure that this doesn't mutate this piece of data, or doesn't, change this or that. So, you know, as I mentioned before, you do end up, in my opinion, do end up writing a little bit more code, and it does sometimes take a little bit, a little bit more effort, I would say, because when you start to think about it in a different way, then you will have to write your program differently. So I'm showing here examples. I mean, as I mentioned earlier, I came from Rails background, so I used to be a Rails developer. We used to teach Rails in our coding bootcamp in Vancouver. So for example, this is a class in Ruby that is using Active Record. Active Record is the object relational mapping library that Rails uses to basically take data and stores it in memory. So in this case here, I have a user, I have an email field for the user. So what I'm doing here, I'm saying validate that the email is present. So the way you do it in Active Record, you say validate email presence true. And then what you would have to do is you say user.create and then email. And then you do, basically you give it the email, and then this will kick the validation for you right here. The way you approach it in Elixir, and the library for Elixir to connect with databases is called Ecto. You create what's called a change set. But notice here how I'm being a lot more verbose. I'm writing a lot more code to just achieve technically the same thing. So I have to take the user. This is what we call a map, a struct. And then you cast this email. You take this email field, and then you call in this function that's validate required. So you're basically chaining functions together. Just remember what I said earlier. Your entire program will be basically chains of functions that calling each other. So I have a function here that basically starts with a struct, a data structure, and then it calls a bunch of functions on it. And similarly, when I want to actually invoke this, I have to basically do this change set. I have to call this change set function, give it this struct, and then I will attempt to insert it into the database. So the note on mutability here, so I can tell you here what validates does. It actually sets a flag in memory. It mutates a flag in memory to tell you whether email is valid or invalid. So it does use mutability, and for that, you get a lot simpler code. And also you get basically a lot more concise code. Versus in Elixir and Ecto, you'll be a little bit more verbose. You have to sometimes do things. You have to write a little bit more code to achieve the same thing. But again, from here, this I know, I write this with somewhat of a sure footing, saying that this will not have side effects. While this one may, if I don't, if I don't write code properly, if I get new people to the team and such, they may write code that ends up basically, causing some side effects, causing things to break elsewhere. So this is why, again, here, even though this is more verbose, I think in the long term, it can basically pay off. All right, so next up, I'll talk about Phoenix. So Phoenix is a framework to rapidly build web applications. It's created by this guy. His name is Chris McCord. Also, you see him in conferences and, very active in the community. And, you could build web apps. And this is what made Elixir as a language shine. Because, sometimes language by itself is even, no matter how elegant it is, you need something that you could build practical applications with. So, the closest parallels I would say is like Elixir is kind of inspired by Ruby in many ways. Again, very different, because Ruby is a language that you can mutate a non-functional, while Elixir is functional. And Elixir, by the way, comes with a lot of other tools and things, like OTP, for instance, that like Ruby wouldn't have something, exactly that parallels to it. Phoenix also is very inspired by Rails. Phoenix as a language, again, it uses like an MVC architecture, and it uses many of the design pattern ideas that you see in like Rails. If you're not familiar with Rails, almost every language have some kind of a framework to build web applications. So in Scala, for example, there is Play, and what others I can think of right now. I think there is Django and Python, and every language usually has like a framework to build web apps, and Phoenix is the one of choice for Elixir. Even though it's heavily inspired by Rails, I think it have a lot less magic. There's a lot more things that you see, more being, let's say like more explicit. Which means you have to write a little bit more code, and it is less opinionated. So you could customize a Phoenix application a little bit more that you would in a Ruby on Rails application. So in my opinion, it's kind of the best of both worlds. I mean, Rails, even if you don't, code with it, it's really a very popular framework. There's many large companies, startups still till this day use Rails, and I still think it's probably very widely popular. Not sure how much growing it is, but it is still very widely used. So what you're getting really with Phoenix, in my opinion, is that you're getting the best patterns from Rails, which has been tested for many years. You're getting a functional programming language, and then you're getting high performance. So in my opinion, it combines a lot of things, and this is one of the biggest reasons we chose it for both Aplicar and CodeCast. In the last 3 years, I've been actively coding with Elixir and Phoenix. All right, so let's talk a little bit about the performance. So how much performance are you getting? Well, this is a little quick test here. It is not unheard of to see requests that take microseconds in Phoenix. I coded again backend a lot with JavaScript and Java and Ruby on Rails, and I would never see microseconds. You always see multiple milliseconds. So this is why, again, this is just a quick kind of, think of it as not very scientific kind of a test, but just seeing that you get requests that are microseconds, just an indicator for how fast you could handle some of these requests. And I'll show you here some different performance that people have done over time, to show you kind of the differences. So this person here has taken different instances of EC2, so different size of servers, and started to do some tests. You could read up more about it. I'll share this presentation with you guys later. And he started to basically kind of compare what you would get with Rails versus Phoenix. Again, you may be using a faster framework than Rails, but still that at least should give you an idea that the performance is really significantly better than you would see on all these different instances when you're comparing Rails to Phoenix. So you're getting a huge amount of performance, just throughput out the door, just you get a significant amount of performance. Another one here is basically compares, also from the founder of Elixir, Jose Valim. So he compares the different frameworks. So Plug and Phoenix are both Elixir, by the way. Plug is, very simple way to handle requests, and it's actually, utilized by Phoenix. Gin is from Golang, Play is from Scala, Express is JavaScript. Then you get Sinatra Rails. I'm not quite sure about what Martini uses, but as you can see here, just the throughput you are getting here is quite significant. So even with languages that are fast, such as Gin, and with Golang and Play with Scala, you're getting superior, or at least let's say very close performance to these ones. And in my opinion, it's I've coded briefly in Scala and Golang. It's when it comes to building web apps, Phoenix is really much better than the other frameworks that you will see out there. So that, with all that said, it wouldn't hurt for you to like spin off a simple, even Hello World or a simple app of sorts, and just compare the performance yourself. See a common use case. The best test to do is a common use case you do. Let's say you take data, you process it, you store it in the database. So build that kind of in both, say, Phoenix and in another language that you use, and then run basically benchmarks to compare the two. Another really cool feature that is with that comes with Phoenix. Now it used to be a separate library. Now it's actually baked into the framework. It's a really nice piece of technology that is called LiveView. So I'll actually do a little bit of a demo for you here. And for that, I will see if I can do this here. I'll share a CodeCast link in the chat. So maybe there's chat here. So I'll share this one. So you should be able to follow it. The only reason I'm using CodeCast for this one, which is, as I mentioned, the tool I co-founded before, is because you're able to actually view the code on the side. Oh, I have to shut it down so you don't hear me twice. Um, so this is basically the app you're seeing over there. So I'll show you, for instance, this snake game right here. Many of you probably familiar with this snake game. Played it on Nokia. If you're old enough like me, you probably played it on these old Nokia phones. It used to come with all of these. It's probably to be the best game on those phones at that time. So you know what you're doing with this game. I'm using the keyboard arrows to take this snake up and down, and every time you hit a red square, the snake grows. And you want to see how far you can go. Like, what's your score before this whole thing? Before you hit a wall. So if you hit a wall, the game will finish and it'll tell you your score. So the first thing you would think is, when you look at this game, you'll be like, well, how would you build it? Well, many of you, the first thing we'll think about it is like, okay, I just need to write some JavaScript. And you could build it with JavaScript. It's actually not very difficult to build with JavaScript. You could build it with that. Interestingly enough, there is, as a developer, you could write the whole thing without having to write any front end code, any JavaScript. So what this is doing is, actually, this is a code for it, which you can see in Snake Live file. And what this is doing is actually re-rendering. Every time you hit an arrow, it re-renders the entire page. Okay, and there's a timer that basically keeps moving it. So this is why you see these X's here. This is the initial state for it, these X's, which you see right here. So what we're doing is we're re-rendering the page every time. Phoenix is so fast. So what it does, it opens a socket with the backend, and the backend keeps pushing changes through the socket. So the entire code for this whole thing is what you see right here, which is all Elixir code. It's all Elixir and Phoenix code using LiveView without having to write any JavaScript. Now, I would have to say that this does use a little bit of pre-written JavaScript on the front end to make this work. You do need some JavaScript to at least open the socket and then replace pieces in the DOM. But that's all you're doing. And if you really have to write JavaScript, there's always hooks and stuff that you could write your own JavaScript. But especially me, coming as a backend developer, I actually like to write as little JavaScript as possible. Because sometimes I'm doing simple things. Like, let's say you populate one drop-down menu, and like, let's say the countries, and then you want to populate the second one with the provinces of that country. So the common use case for it is that you make an AJAX request and you get a new list, or you put it all in the front end and you use JavaScript to, when you select something, to replace the second drop-down menu with all the other things. Now, with Phoenix, you could actually do it completely on the back end. So basically, you could have a large amount of code written on back end. And this is another example here. Again, no JavaScript here, the custom JavaScript, I should say, written to make this work. So some things like autocomplete, also like a very common use case. Automatic scrolls is an example, like as you basically scroll is a common use case. So all these things, you're now able to do them using LiveView. And by the way, we use LiveView on both Aplicar, and we use LiveView on CodeCast as well, and it works very well on production. So it's been, again, tested, and many people use it on production as well. Another important thing to say about when you're picking a framework is that you have to see what, does it have packages for all the common use cases for applications? And I would say, Phoenix has been around enough that, all the packages for most popular use cases are there. So you're not going to face a case where, I need this library and I have to build it from scratch. It's rarely the case. I mean, you probably would have to do it, say you're connecting to some not as popular API, or some use case that isn't as common. You might see a library in other framework, but not in Phoenix or not in Elixir, and that may happen. But honestly, for I'd say the vast majority of cases, you're able to find packages that are well tested and well maintained for Phoenix. And it really has an awesome and growing community. Like, you Google up any problem with Elixir or Phoenix, you will very likely find an answer on Elixir forums, on Stack Overflow. Also, if you're stuck on something, especially with newer technology, you could go to the Slack channel, and the people are very helpful and responsive. And in my opinion, that's a very important attribute of a language and framework when you're selecting them, because it will influence how you code. It doesn't matter, again, if you have the best language, if it doesn't have the communities that support the tooling around it. It makes it hard to code with that language. In my opinion, here again, it's purely my opinion. And again, sorry, now I'm comparing a lot Rails with Phoenix simply because I came from a Rails background. But many of you, even the non-Rails developers, should get like at least a sense for what that may mean. Rails, I would say, if you want to develop an MVP, I would say Rails is still faster. So development time wise. So if you want to develop an application, it'll still be quicker for me as a Rails developer, knowing, let's say I have the same amount of knowledge with both Rails and Phoenix. It'll still be quicker to build it in Rails than to build it in Phoenix. There's still more gems available for Rails. It's been around longer. But given the performance and maintainability, it's probably likely worth using Phoenix. So if you think about, like, okay, my project is going to live for more than 1 year, it's going to live for a while, and it's basically going to grow, and I'm going to need performance down the road, then I would say, probably using Phoenix makes more sense. That said, like any good engineer, you use the right tool for the right job. If you're building a small app that you don't think is going to grow, or you're building something for a client you're just going to build once and deploy and that's it, I think Rails is still a fantastic tool. Again, Rails is still very, very popular in many companies here in Vancouver, in Canada, and I think in many other places as well. Express.js, for example, has the advantage of having the whole language using JavaScript. So that is an advantage if you like JavaScript, right? I personally do not like to write JavaScript that much. So that's why I wouldn't see that as a huge advantage, but some of you might. And that may be a way why you would pick, for example, Express.js or Next.js or some of these other ones where it enables you to write the entire stack in JavaScript. Because, and again, even though Live View enables you to do a lot without JavaScript, at some point you would have to write some JavaScript, right? So you end up with some JavaScript and a lot of Phoenix. But in cases where you want to write more JavaScript, probably it could make advantage to have the whole stack written in that JavaScript language. In my opinion, probably the biggest challenge is finding developers. Not, again, there's a good number of developers out there, but it is, the demand for Phoenix is growing, and not as many experienced developers. But what happens is, for me as a CTO and of a company, what we do, sometimes we hire somebody who don't know Elixir and Phoenix, and then we train them up. Of course, always the preference is for somebody who already knows Elixir, or who already comes up with knowledge with functional languages. That said, many companies are training up people. So to many of you at VanHack here, this could present an opportunity because, for example, if say you're a Java developer, or let's say you're a Rails developer, or a JavaScript developer, there's more demand for these for these languages out there, and you can probably see it by simply searching for how many Elixir jobs versus Rails jobs, say on the VanHack portal or on job websites. But I would say you could really stand out if you're really good at Elixir and Phoenix, because even though the pool is smaller, for one thing, it's growing. And the other thing, there's even a lot fewer developers, so the competition with you will be a lot less. So and many companies, again, do hire remotely or do bring people to Canada or something. So again, in my opinion, it is something to consider. If you, again, the primary thing is like to see, do you enjoy that language? Do you enjoy that framework? And if that's the case, then it could be this particular challenge could present an opportunity for you for something to specialize in and to stand out with. And for both Aplicar and CodeCast, we're probably hiring in the new year. So connect with me on the social media, on CodeCast, on LinkedIn, and yeah, I'll be announcing when we're hiring, and if you're interested and your skills are good, we could end up working together. So lastly, I want to talk about deploying Elixir and Phoenix apps. And one interesting thing about Elixir is that the tooling from Erlang, because remember how Elixir compiles to the Beam, compiles to the Erlang virtual machine, which means that you could actually use any tools that are there for Erlang. You could just use it for Elixir because they compile to the same thing. You could even actually write Erlang code within your Elixir. So technically, you could have your entire stack using just Erlang. Okay, so you could have like your HTTP server instead of using Nginx, you could have an Erlang solution for this. For processing requests, of course, you would use that. For long running requests, usually you use Redis, Go. There's built-in solutions for all of these within the Erlang ecosystem. All right, so that said, also like we deploy on GigaElixir, which is similar to Heroku. You could easily deploy with Docker. So just to kind of finish off the thing with deployment. You could a lot of these ready to deploy platforms are supporting Elixir. So again, deployment, I don't think it will be an issue for you at all. So let's say you're feeling excited, you want to go ahead and try Elixir. How do you go about it? In my opinion, it's really relatively easy to learn. You don't really need knowledge of math or computer science theory to get started. And this is what I really like about Elixir. I would say out of the functional languages, it's probably the most approachable, the ones that is the easiest, even for a junior developer with say 6 months of experience, or even I can't see. I mean, I don't know if it exists out there, but I can't see why this Elixir can be the first language that somebody learns. But if you already know something, I think Elixir will be a relatively easy language for you to learn. The documentation of both are great, Elixir and Phoenix. There are some good books out there. I like these two books. I started learning by these two books from the Pragmatic Bookshelf, Pragmatic Programmer, Programming Phoenix, and Programming Elixir. Um, Other resources here as well. Again, I'll share a PDF after this presentation with the VanHack people, and then they'll share it with you guys. So Elixir School, Udemy, Exercism, Pluralsight, and then YouTube. There's tons of content out there, and I have started a series on CodeCast also for teaching Elixir. Again, contact me if it's interested. When the series is up, I will let you know about it. I've already put 5 or 6 episodes. I used to be a teacher, and I really enjoy teaching and I enjoy Elixir, so I'm going to be putting more and more content on CodeCast for it. So just hit me up if you're interested in learning more about this. So you're getting close to the time here. Thank you very much for giving me this opportunity. Again, my name is Tam, and happy to take your questions about my presentation.
Okay, awesome. Thank you so much, Tam, for such a detailed and full of guidance and inspiration about all about Elixir, Phoenix, and all the things that people needed to
Mhm.
know. So, yeah, thank you so much about that. We're moving towards the question and answer session. Yes, this is the first question. Does Elixir uses garbage collector, ARC, or you know better? Thank you. Yes. Sorry, I don't know how to pronounce that. Okay.
Yes, it does. So it does have a built-in garbage collector, so you wouldn't have to worry about basically cleaning up after your own. Um, when you set a variable or when you allocate something in memory, you wouldn't have
Mhm.
to worry about it. So yeah, it does have, and that's part of, in my opinion, that's part of what makes it relatively easier to deal with.
Perfect. Another question is, if I'm creating a new structure, data, state, and Elixir for each element in a large list, how is Elixir keeping us so that it would not cause any out of the memory issue? Adrian is asking.
That's interesting. I mean, uh, I'm not sure if Elixir has out of the box solutions for something like this. There may be some libraries or things that will help you deal. Let's say, like, I'm assuming that you mean that your data structure is in a sense that like it fills more than the memory. So I would say there may be some techniques or some approaches that you would have to take to do it. What I can tell you is that the processing with Elixir, let's say you're processing a large list, you could easily multi-thread and parallelize that in a way that at least processing the list will be extremely fast. So that's the one thing I know for sure, that Elixir can give you out of the box, that even just using the standard data processing, structure processing kind of libraries that are built in with Elixir, you can get a lot of gain that way. But if you just it's for memory, again, never had to deal with this, so I cannot give you a concrete solution here. But my guess is like looking at how many bigger companies are dealing with large data sets in Elixir. I'm pretty sure there are some solutions out there for this.
Perfect. Perfect. Thank you so much. Moving on to the next one. Does Phoenix provides async IO like how Node operates, or can we implement it? Abid is asking.
Um, I'm not familiar with the async IO, but like what I can tell you that Phoenix provides and what's really good at is easily opening sockets between the front end and the back end, and basically just interactively pushing things back and forth. So you want to update something easily on the client end, you could easily open a socket and do it that way. I'll have to look in how like Node does it because I haven't coded in Node for a very long time. But yeah, like in general, I can tell you that Elixir does not block. Like there's nothing in Elixir that would block your coding. So you never have to worry about like one process holding up the entire thing and blocking. Just as I mentioned, out of the box, this multi-parallelism that's coming, then you're not worried. Yeah, like you can open a socket and then you're not worried about anything blocking. So if that is a concern, then out of the box, Elixir does not block, doesn't wait for anything. So in that sense, I would say, yeah, it probably be very similar to Node, none, if not even better.
Awesome. Moving on to any example or app portal build with Elixir plus Phoenix. Elvaro is asking.
Yeah. So probably the one that you're most familiar with is Discord. Discord is the chat
Yeah.
app. I think it was acquired by, was it Microsoft or Salesforce? I don't remember, but it's basically massive app built Elixir and Phoenix. I know Brex is a company that uses Elixir Phoenix heavily, and I can tell you the ones PepsiCo. I know they were hiring heavily in the last Elixir Conf. They use also Elixir and Phoenix. So those are the ones that comes to mind. I'm pretty sure there are many others as well, that uses Elixir and Phoenix.
Hmm. Great. That's awesome. Is Elixir suitable for robotics and IoT application projects? Chongweng is asking.
Yeah, it's an excellent question. There's a framework called Nerves. Oh, I'm not sharing my screen anymore. I'll probably share, but let me just share.
Sure, sure.
I'll share it in the chat maybe. This project here in Elixir, I've seen it in the last couple of. There was a good number of talks in the last couple of conferences in Elixir. It's growing. I'm not sure how it compares with the other ones. Like I know people were coding robotics with JavaScript and some other ones. In my opinion, it's extremely like Elixir is extremely suitable for something like this because of the non-blocking nature. So if you're waiting for different inputs from different sensors, you could have multi-threads dealing with those without having to block your entire program while you're waiting for input um, from sensors and such. That said, I just as a library, how developed it is, I'm unsure. I haven't actually coded with this particular library, but I've seen some really cool things people are doing when I watch these talks. And yeah, if you Google up like Nerves Phoenix, sorry, Nerves, it's not Phoenix, it's an Elixir library. So Nerves with Elixir, and then watch some of these talks on YouTube. I think it'll give you an idea for what the library can do. Or you could even check like just their site and see what what kind of tools. Because I know some of my students in the bootcamp used to do some like small robotics projects with JavaScript, and I remember that the key thing was like how many different types of hardware you could integrate with, and that usually just comes with time by more people adding some more support for different pieces of hardware. And just not sure what's the state for Nerve's project, but I know it's possible, and I can tell you Elixir as a language is very suitable for this.
Perfect. So how's the connector support? Are connectors for most of the DBs available by App?
Absolutely. We use Postgres. There's connectors for Mongo. Um, I mean, I wouldn't use the word ORM because ORM says object relational mapping, and using functional languages, we try to avoid using the word object, not to confuse it with like, say, objects in Java or Ruby that like, even though you could think of structures as objects, but just to avoid that terminology, not to confuse things. But yeah, you could connect to Mongo. The most popular one is Ecto, which we use for Postgres, and you could connect to pretty much anything. So again, that will not be an issue at all.
Perfect, perfect. So does Elixir implement supports monads natively, or we need to use specific libraries? Adrian.
I do believe you need to use specific libraries for these. Yeah. But I mean, again, coding Phoenix, I've never had to really deal with having to build my own monads. So that's the other thing. Like, you almost never have to do it. So I do believe you will need specific libraries for this.
Great. That's wonderful. So are there any unit testing support in Elixir? How about testing libraries?
Yes. So there is EX unit that comes built in. It's really like, it comes with really awesome syntax. Like, you could even like, your test can be your documentation in some ways. Like, you could write some kind of pseudocode above each function, and that could serve as the test, and it could be at the same time the example for documenting that particular function. I really like that feature of EX unit. Testing libraries, I have to say, like, they are, like, I would say like the Rails ones are a little bit more developed than, say, the Phoenix ones. We do encounter some edge cases, like, let's say you want to mock an HTTP request to a third party library like Stripe or something. Like, we did run into some issues with that, but eventually we found solutions. There is some mocking libraries. There is some like, like, for example, we use VCR and
Mm.
EXMock for things like this, and just a built-in support with Elixir and Phoenix just does a lot out of the bat. Like, you could mimic HTTP request, you could check for request response and that type of thing. So, and conceptually, testing is easier, like I was saying, in functional languages, because of the nature that you just have to know the input and the output of the function. You wouldn't have to worry about a previous function having to set something, or having to modify or mutate data, because you know that there's no data mutability. So all you have to worry about is what's the input to that function, and then what do you expect the output to be. And like, there's, for example, factory support. Ex Machina is the one we use, another good library to help you generate factories to help you set up your tests. So I would say, like, you're not going to run into major issues, but there may be some of these things on the edges that you may have to write your own custom solutions for it. But overall, the testing ecosystem in Elixir and Phoenix is great.
Perfect. Now we're gonna have, because we're short on time, we have just 1 minute left. It's the last question we'll be having. Does Elixir compile to native, or it uses a virtual machine?
It uses the Erlang virtual machine. So it compiles to the Beam, basically, which is the Erlang virtual machine. And yeah, it's fast. You could leverage a lot of the things from the Erlang language and such.
Perfect. Thank you so much, Tam, for telling everybody in detail about all about Elixir and all about your knowledge and all about the things that you're doing, especially regarding your projects and regarding
Mhm.
company, everything. So thank you so much for being part of this conference. It was a delight to have you here.
Thank you for having me. Thank you for putting this together. I'm very passionate about coding and coding education. So yeah, all of you connect with me on LinkedIn, social media, and would love to interact with you in one way or another.
Everybody, reach out to him on LinkedIn if you have any questions. We'll be moving on for the next webinar soon in 10 minutes. So stay tuned and we'll be back shortly.